Up until this point, you've been writing code using only Apple's first-party frameworks. Now it's time to start investigating the world of third-party libraries and frameworks. In order to do this effectively, it's usually beneficial to use a tool that can help make integrating external code quick and painless. In this section, we'll be discussing the three most popular dependency management tools in the Swift ecosystem, their pros and cons, and we'll go into more detail regarding CocoaPods, which is our recommended tool for new Swift developers. The first tool we'll overview is CocoaPods, the longest established third-party dependency management tool, having its first release in 2011. Next is Carthage, a newer third-party tool with a different approach to CocoaPods. Finally, we have Apple's own first-party Swift Package Manager tool, the newest solution, having arrived with Swift 3 in 2016. Let's have a look at some pros and cons of all of these tools as objectively as possible. Starting with CocoaPods, it's a very well established and stable tool that reached version 1 in 2016. This means users can expect stability in its API and should not expect to have to work around large changes in the tool in the near future. This certainly wasn't the case prior to version 1. It has a large and responsive development team with a great website and tools that can help you find libraries in its huge selection. It has a low barrier of entry, meaning you can get started using libraries with it quickly and easily. In fact, this is its main selling point, and the reason it's probably the best tool suited to new Swift developers. In terms of its drawbacks, however, CocoaPods presents challenges when projects become very large with large numbers of dependencies. Primarily, this is because it's a source code-based tool. This means that working with it in large projects often leads to a lot of unnecessary compile time, which can become a significant disadvantage. It's also written in the scripting language Ruby. Whilst this isn't a problem to get started, it can certainly become inconvenient for more advanced usages. Another disadvantage is that using it requires some maintenance of a Ruby environment on your development machine, which can also be an inconvenience. Finally, due to its low barrier of entry, you'll find that locating high-quality libraries can be a challenge at times. Often you'll need to audition many libraries in order to find which best suits your needs and which is well implemented. This is, however, always an important step when using third-party dependencies, regardless of which toolchain you use. Moving on to Carthage, Carthage takes a very different approach to CocoaPods. It doesn't work by integrating the source code of external libraries into your project. Instead, it uses a similar dependency description file to build binary frameworks or modules that you must then integrate yourself into your project. This solves the build performance issues that can arise with CocoaPods. This may make Carthage a good choice for a larger project that has begun to outgrow CocoaPods. Fundamentally, it does a lot less for the user automatically than CocoaPods. This also means it offers greater flexibility, but at the cost of a higher barrier of entry. Another advantage is that it's decentralized and doesn't rely on a central repository of definitions, as CocoaPods does. This means this tool has no availability issues, which has been a problem at some points in CocoaPods history. With respect to its disadvantages, it's not a good choice for a quick start and also requires a much better understanding of how the Xcode build process actually works. This means it's not a good choice for those users who are only just getting started with Xcode projects and are not yet confident customizing the build process. Furthermore, its shorter history and higher barrier of entry means it is not as well supported in the developer community. This does have the side advantage that libraries supporting Carthage may come from more advanced developers, which may mean better code quality. It doesn't have the evolved online presence of CocoaPods and doesn't have any search and discovery tools, making finding libraries not as easy. It has also not yet reached version 1, so may not be as stable in terms of its features. Finally, let's look at Swift's new native package manager. Its primary benefit, at least considering the future, is that it's a first-party native solution that's part of the Swift language ecosystem itself. CocoaPods and Carthage are examples of third-party tools that were created to support the lack of any native dependency management tool. Objective-C, for example, never had its own package manager. This means it's well integrated into Swift itself with package syntax that is expressed in the Swift language, without any custom format as with CocoaPods or Carthage. Since CocoaPods and Carthage are focused on the needs of Xcode-based development, This may mean that Swift Package Manager is the best solution for Linux-based server development. Overall, it's also possible that in the long term, the Package Manager will become the accepted Swift dependency management tool. On the other hand, the Package Manager is still relatively new and has nowhere near the same momentum behind it in the third-party developer community. That said, it's also an open source tool, and its support is likely to grow over time. It also does not have the same search and discovery tools that CocoaPods benefits from, although IBM have developed a package search web app at the URL packagecatalog.com, which may be a good solution at this time. As another possible disadvantage, speaking from many years of experience in the Apple developer community, there may also be some concern as to whether or not the package manager will adequately support the needs of the third-party developer community going forward. For example, being slow to adopt new features that may go against Apple's own view of the development process. So to conclude, we recommend you get started using CocoaPods. The reasoning is very simple. It's the most automatic of the tools. You'll be able to create a simple pod file and start using third-party libraries right away without needing to understand its functioning in great detail. What's more, you can continue using it up until the point your requirements are advanced enough that you outgrow it, if that time comes at all. None of these tools lock you into their system. Of course, you'll need to redefine your dependencies and reintegrate your project if you do make a change, but this is a common consideration in all development projects. What's more, CocoaPods is very high profile in the Cocoa development community. Whilst many developers may favor other tools, it'll be quite rare to find Cocoa developers that do not have experience working with it. Therefore, you can consider CocoaPods to be the most mainstream dependency management tool, or at least it is for now. So let's go through the complete process of installing CocoaPods and adding some dependencies to an Xcode project. The first step will be installing the CocoaPods Rubygem. If you're unfamiliar with it, gems are the Ruby language's own dependency management system. In order to get started with CocoaPods, you'll only need to use a few simple commands. However, as you work with CocoaPods, you'll inevitably require greater understanding of how Rubygems work. This is, of course, one of the potential drawbacks we noted with regards to CocoaPods. Needless to say, this step is only required the first time you start working with CocoaPods on a particular development machine. Once we have the administration out of the way, we can start the more productive process of discovering some libraries and frameworks. In the CocoaPods community, these are known as pods. We'll look at the CocoaPods website as well as using the command line discovery tool. Once we've selected one or more pods, we'll create our first pod file. This is a description of the pods we would like to integrate with a particular project. The pod file is actually a piece of Ruby code. However, you'll see that its format is reasonably friendly for simple usage. Once we've created our pod file with the description of and it will go ahead and install the gem. Now you can use the pod command. You may need to open a new terminal window or use the command #rf just to register the new commands. But then you'll see you now have the pod command line tool, which is the main tool you'll be using to interact with CocoaPods. So the next thing we're going to do is have a look at the CocoaPods search and discovery tools. Here I'm on the CocoaPods website, cocoapods.org, and at the home page here you see we have a very prominent search box and we can search for pods here. I'm going to search for one with a small pod we'll be using as an example. It's called result, and if we enter that in the search box, we see we have a whole lot of controls here. We can select the platform we're looking for, the language. It's actually a Swift pod, so we can select that as well. Perhaps we're looking for Mac OS as a supported platform. Notice also there is a sort by box here with sort by quality as the default option. It can be quite challenging to find high quality pods, so the CocoaPods team have done some work to try to analyze which pods are of quality. In any case, we have a list of results here, and the one I'm interested in here is called result. If we open the page, we have a lot of information about the pod from the GitHub repository source, and this is the README. We can find a lot of statistics about it as well, which is a good indicator of whether or not you're looking at a popular high quality pod. So this is always a good place to get started when you're searching for CocoaPods. The other option we have for searching for CocoaPods is using the pod command line tool. Now the first time you use the tool, it needs to set up its clone of the shared pod repository. This is one of the features of CocoaPods and also sometimes one of the drawbacks, because the repository is quite huge these days. You can run that step manually by using the pod setup command. I've actually already run this on my local installation, so it won't have to do very much. But if you're doing this for the first time, it's quite a long process, can take up to 10 minutes. And I'm just going to run that now, and it's just going to check that everything's up to date, which shouldn't be very much work because I do have the latest version. We'll just let that complete now. Okay, and that's done. And once we have CocoaPods set up with the local clone, I can now use the pod search command. And again, I'm going to search for the result pod and just let that search. And here we have a selection of pod search. The one I'm looking for here is the one at the top. Notice that we have this command here, which is the pod file line that we'll be using to install this pod. That's also available on the web app. I'm just going to copy this text so I can use it when we create the pod file in just a moment. Okay, so now the final step, now that we've installed, set up and also searched for a pod with CocoaPods, is to install a pod into an Xcode project. I've created an empty project here called Pod Example. Now the most important thing to take note of in your project is the name of the target that you want to install your pod into. So in my case this is Pod Example to match the project name. This is very important when we edit the pod file, which we're going to do now. So let's return to the terminal. And still I'm in the directory of the project, and I'm going to use a convenience command, pod init. And you'll see that this creates a file called pod file in your project directory. So this is just a text file. It's actually a Ruby code file. You can edit this using any text editor you wish. Let's open it up now and have a look. And let's go through a few important points. So the first one here at the top, uncomment the next line to define a global platform for your project. So we need to state which platform we're developing for. So let's uncomment this line. The default is iOS 9.0. In my example, I'm going to change this to macOS, and I'm going to change the version number to 10.12. Now, usually it's very important to take care to match the version requirement of your project and the version requirements of your pods, but this won't be a problem for this simple example. Okay, so the next point here, we have the target pod example do block, which ends here at the bottom with end. This is where we are specifying the pods for the target pod example. So take note of this line here. Comment the next line if you're not using Swift and don't want to use dynamic frameworks. So when we're working with Swift, we always need to have this line here, use frameworks, exclamation point. So let's just leave that in. And now the final important point, the bottom here, is pods for pod example. This is where we're actually going to list our pod dependencies for this target. So when I search for the result pod, I copied the pod file, and I'll just paste it in now. And as you can see, the format is pod, then the name of the pod, and this last string at the end here specifies the version of the pod that you're looking for. Now there's a lot of different options here. You can specify the version strictly or quite loosely. This becomes much more important when you start to have larger number of pod dependencies that have their own dependencies, and you can also get conflicts. So take care with the version numbers there, but I'll just be leaving it here at version 3.2.3, which is the latest version. And this arrow here specifies a loose dependency. So now I'm just going to save that file and exit out. And the last command we need to run is pod install, which will read the pod file and install the pod dependencies into our project. So let's just run that now. Okay, and that's done. So let's have a look again at our project directory. You'll see that the file that's been created here is a Xcode Workspace file with the extension XC Workspace. There's also a pods directory here and a podfile.lock, which specifies the versions that we've installed. So the important thing we need to do now is to return to Xcode. This is the project file I have open. So what I'm going to do now is close the project file and go back to my project directory. And this time we want to open the Workspace file. So we haven't worked with workspaces before, but workspaces are a place where you can place a number of projects that may be related. It's a simple container. So let's open the workspace now, and you'll see that in the project workspace, we have the original pod example, and we also have another project here called Pods, which is the CocoaPods generated project which will build your dependencies. If we look again here in the Pods project, you'll see we have Pods, result, and you see we have here the source code for the result library. There are two files, so you'll be able to browse the source code. So the final step is to build our project. Just going to build it using the regular build command. Let's let that work. Okay, and it's built successfully. Now let's return to our source code in the pod example. And the final thing to do is actually to use the code from the library. So it will be imported into a module, and the module will match the name of the library. So in this case, import result. And you see here we have the result type appears, and I'm just going to create a value there, foo, and let's run the project. Okay, so now we've installed a pod into our project. Let's open the workspace file that CocoaPods created. We'll be needing to work with the workspace file from now on. And you'll see that if we look in our workspace, we have now two projects. On the left hand side we have pod example, which is our original project, and a second project here called pods. So we have two projects which are contained inside the workspace. So the pods project contains the source code of all of the pods that we install. If you have a look in the targets, there's pods, pod example, and also result, the pod that we installed. And if you look in the pods folder, you see pods, result, and we have here two source code files which are the source code of the result library. There are two files here. So this is quite an advantage of CocoaPods, that we're really exposed to the source code of the libraries, which can be quite beneficial when you're learning about the way these libraries are implemented. Okay, so now let's build the project again, just as before, using the same target pod example, except this time we'll be compiling and linking the result library. So let's import the library, import result. The name of the module to import will almost always match the name of the pod that you installed. So in the case of result, if we start typing, you'll see we have here the two types, result and result protocol, that are installed as part of the pod. So let's also, if we jump to definition of the module result itself, we'll get an auto-generated interface file in Xcode with all of the contents of the public interface of that library. Here it is now. So this is everything that the library includes as a public interface, just in the same way we're used to looking at it in Xcode when we're browsing Foundation, for example.